Welcome to Spacecraft Guide, the channel that goes over the most iconic spacecraft in the world. In this issue of Spacecraft Guide, we are going to go over a new part of the communication panel in the lunar lander, panel 12. Specifically, we're going to go over the antenna pitch indicator. So when you click on it, test, test, test. It takes you to the S-band Steerable Antenna Pitch Indicator. Now what this thing does is it displays the pitch angle of the S-band steerable antenna, and the limits are from 225 degrees above to 75 degrees below the plane, parallel to the lunar module's YZ plane. So that is going up and down, that's pitch. And this is kind of difficult to understand. So we're going to go into the schematics here and we're going to take a deep dive. So we look at it, and here down at the bottom is the pitch indicator. Now you can see that comes from the steerable antenna electronics. And here is where you manually position the pitch. So when you click it to 30 degrees will indicate down here. But there's also, we have the AGC steerable of S-band receiver in use. And AGC stands for auto gain control. So what that's doing is it's telling how strong the signal is and putting that into the steerable antenna. So we move the antenna and we get the strength coming in, and then we find out if that's a good signal or not. So to look and see how the AGC sample of the S-band receiver in use is, we have to go down to another schematic, which is down here. And you can see it's right here, antenna tracking AGC sample. So that's where it came in. Now, what you have to do is you got to look all the way down here for the signal that's being received. So we got to get from there to here. So, and all through all of this mess, but it's really, really easy. You just got to follow me here. So it starts out, the signal comes in at 2108.8 MC, so that's the signal coming in. But as we get the amplifiers, we have here a second mixer. Now what that is, it's like if you're going on a journey and you have a scout to look up ahead, that's what this second mixer does, is it breaks off this 9.5, a smaller signal, and that signal is going to scout out where the best way to shift the antenna. So that goes up here, or that comes up here, and we can see that it goes all the way through. And what it is doing is it is setting up how the signal strength right here is looking. So it comes up to the top, it looks at the detector and filter. Now that's detecting the signal strength. Here it's going to be displayed. That you see here again, AGC filter and amplifier. AGC, again, the auto gain control, which is working off 9.5, comes back down in here. And that signal, as it's sent over to the antenna, it's going to say, all right, let's go up a degree, let's go down a degree, let's see what the difference is. And that will come into this part right here. So we've got the signal strength coming in. Well, actually it's right here, and it's coming in measuring how strong this 9.5 MC is. If it gets too low, then it's going to send that to the tracking antenna, and that is going to come up here to the steerable antenna, and this is what moves it. And by the movement, will detect the signal off that 9.5. If it's much lower than 9.5, then the antenna will steer the pitch either up or down to wherever the signal is getting stronger. But that's just this signal. So we've got the steerable antenna and it's got the correct frequency. Now we need to get that over here to this receiver's right on this side for the S-band transmitter. So if we look down here at this mess, we see that this is the S-band, received S-band voice, PNR, and digital uplink or voice backup. It comes into the RF switch, and it all up here did all that steering with all the bypass. Now it comes down right here to the S-band receiver, and that's number 2 here, and it also, it's a redundant system, so it's the same as number 1, which is right receiver number 2 and receiver number 1. So then the antenna comes into the receivers, and now we can get whatever they were saying from Earth, and the antenna is pointed the correct way, and then when the astronauts transmitted, it would be with the strongest signal strength from the moon back to the Earth. So if you really want to look at what everything I said, it's all in this paragraph. So all that time I took is right in here. I just tried to make it simple. And if you look right here, it says on a portion of the VCO, or the voltage controlled oscillator output, is routed through a series of frequency dividers networks that reduces the frequency to 9.2 kc. Then we hit it as 9.5. This frequency is compared to the output, also reduced to 9.2 of a 4.7 MC crystal oscillator in phase detector. Okay, so that's how they're comparing. They've got one going one way, one signal, and comparing it to the signal of the other, the frequency coming in compared to the signal going out. The signal going out would be from the lunar module, which of course would be higher than the signal coming in. That's what you're trying to get, the one phase up to the other. And then the two inputs of the phase detector are normally 90 degrees out of phase, and that difference is represented as a voltage, as the phase detector output is controlled by the VOC, the voltage controlled oscillator, frequency stability. So again, taking what we said before, what we're doing, we come down here, taking in the signal, breaking it. It comes in very high, breaking a small signal, because if it's really small, it doesn't take that much energy, so it'll not use as much energy or power, electrical power, and that comes over here to the detector, and then it's compared with the amplifier and filter to see at the outbound if it's getting, or the outbound signal, we'll see if it's getting closer to it. And then if it is, then we get a bigger signal strength. So that was a lot that I went through today on this episode, but I hope you understand a little bit better what it took to get the steerable antenna electronics to work, where it was getting its data either manually or which was real easy, you just turn it, as compared to the automatic way, which is a lot longer and takes a little bit more brain power to understand, but that is how it works. That's all for this week. If you would like to use this interactive virtual reality exhibit on the command module, the lunar module, and the surface of the moon, just go to our Patreon page, and the link will be down below.